All right, we are at our final step in this problem, which I know has been quite a doozy. We first found the equation of a line passing through point A that was perpendicular to a given line. Next, we used our old skill of systems of equations. We substituted the one equation of a line for the letter y. We made the two lines equal to each other, and we solved for x. What we got was this number, which is the same as negative 1.2 as a decimal, and we plugged that in for y, and we got 12/5 or 2.4 as a decimal. Now our final step is here. We need the distance between this dot and this dot. We're going to use our distance formula here. I'll copy the formula. We have x2 minus x1 squared plus y2 minus y1 squared, and all of that under the square root. I'm going to go ahead and plug in those numbers right now. So I'll start by calling this x1, y1, and x2, y2. So x2 is negative 1.2 minus x1 is 4 squared plus 2.4 minus 5 squared. And yes, you're going to need a calculator on this. With all these squares and square roots, there's simply no other way. Next step, simplify what's inside parentheses. This would be a negative 5.2. And this would be, let's see here, 2.6. Remember, if you end up with a negative here, it doesn't really matter because that's going to get squared. So my first step, 5.2 squared. 5.2 squared. That's the sound of me clicking on a calculator in the background. We've got 27.04. It is positive because negative times negative is a positive. Plus, and we have 2.6 times 2.6. And that equals 6.76. I'm going to add the two together in my next step. And that equals 33.8. So the square root of 33.8 is the distance from A to the line. To get that final distance, I use the square root, and I get 5.81. I'm going to go ahead and round it to the hundreds. 5.813 is rounded to 5.81. So my distance, the actual distance is the square root 33.8. That is the exact number. And if I plug in that square root, I get a really long decimal, but the approximate rounded answer to the hundreds is 5.81. Now, there's just two problems of this on the homework. I do want you guys to try them and use your best judgment. One will look like this. It'll give you a picture. The next one might be a little bit different. It just gives you the equation, but it's the same idea. First, you're going to need the perpendicular line to this equation and going through point A. Second step, once you have that, use systems of equations to find the intersection point. And third step, use distance formula to solve the distance between the intersection point and the point that was given to you. All right, guys, best of luck. This is a very tough problem. It's probably the toughest in IM1. It's always has been. So I thank your minds and your hearts, and I hope you guys are having a good day. All right, bye.